Now let's look at some practice applying the concepts of density. Let's look at this first problem. What is the density of metal if a 100-gram sample added to a cylinder of water causes the water level to rise from 25 mils to 37.8 mils? Okay, so pause this lecture and see if you can work it out. And when you're done, start it again and I'll work it out and we'll see if we're on the same page. Okay, so the first thing that I do is write down my given and my wanted. I want the density and I'm giving the mass and I'm given the information to calculate the volume. This is a displacement, so we've got to subtract, and this is my answer in correct sig figs. Both of these values have our last significant digit here and one place after the decimal point, and so that's my that's where my last significant digit is for my answer. So we're going to apply our equation that density is mass over volume, and so the mass is 100.0 grams and the volume is 12.8 milliliters. So then we let our calculator do the math, and my calculator tells me 7.8125. Okay, let's take a look at our sig figs. My units are going to be grams per milliliter. Let's look at our sig figs. This is a division problem, and the rules for division is our answer has as many sig figs as the value with the least. This has 4 sig figs, this has 3, so my answer can only have 3. My 1 is my last allowable digit. I look to the right, 2 is less than 5, so 7.81 grams per milliliter is the correct answer. Now, they didn't specifically ask for grams per centimeter cubed, but they did say it was a metal, so just to be consistent, we'll write this as grams per centimeter cubed since we're looking at a solid. Remember, a milliliter is the same as a centimeter cubed. Now let's look at another example. What volume does 100 grams of marble occupy? And its density is given as 4.00 grams per centimeter cubed. Okay, it doesn't ask for a specific unit here, so our unit of volume, I guess, will be centimeter cubed. So pause the lecture and see what you get, and then start it when you get an answer, and we'll see if we're on the same page. Okay, so we write out what we're given, which is 100 grams, and that is our mass. We're also given 4 grams per centimeter cubed, which is our density, and we want volume. And if we remember back to our other slide, we see that volume can be calculated by dividing mass by density. Whoops, I wrote this down wrong. And I would have figured this out when I went to look at my units that I wrote it down wrong. So my mass is 100.0 grams. My density is 4.00 grams per centimeter cubed. And this is where our units come in. Our grams cancel out. Grams divided by grams is 1. And then we have this denominator in the denominator. And what we do is I always think of this as dividing by a fraction. When you divide by a fraction, you flip the second. Our centimeter cube actually comes up as our new unit. And 100 divided by 4 is 25. Now let's take a look at our sig figs. Again, we did division. 3 sig figs here. Excuse me, 4 sig figs here, 3 sig figs here. My answer should have 3 sig figs. So to correctly express this in 3 sig figs, I'm going to write 25.0 centimeter cubed. Now let's look at a more complicated example. A 55.9 kilogram person displaces 57.2 liters of water when submerged in a water tank. What is the density of the person in grams per centimeter cubed? Okay, so the first thing we want to do is we want to write down our given quantity and our units. We want, we're given mass, we're given volume, and then we write down what what we want. We want our density in grams per centimeter cubed. Now we know to get density, we're going to divide our mass by our volume. But if we take the mass that we're given here and the volume and divide them, we won't have the units that we want. So what I'm going to do is I'm going to take my mass and convert it to grams, and then the volume and convert it to centimeters cubed. So for my mass, my conversion factor is 1 kilogram is equal to 1 times 10 to the third grams. 1, gram, and kilo means 10 to the third. Then I'm going to set up my railroad math. 55.9 kilograms, and then my conversion factor, kilogram goes on the bottom since that's what I want to cancel out, and gram goes on the top. My kilograms cancel out, and when I express my answer in scientific notation, we get 5.59 times 10 to the fourth grams. And I have the same number of sig figs that I started with. Now let's look at my volume. My volume, my conversion factor is, I have two I can use. This one came from a slide. 1,000 centimeters cubed is a milliliter. Or I can use 1 milliliter is equal to 1 times 10 to the minus 3 liter. And therefore, 1 centimeter cubed is equal to 1 times 10 to the minus 3 liter. So I use my conversion factor here doing my translation. 1 milli means 10 to the minus third, liter, and since a milliliter and a centimeter cubed are the same, I can use this conversion factor. So this is the conversion factor I'm going to use, but if you use this one, you'll end up with the same answer. And my volume that I'm given is 57.2 liters. I want to cancel out liter, so 1 times 10 to the minus 3 goes on the bottom, centimeter cubed goes on the top, and when I express my answer in correct sig figs and in scientific notation, it's 5.72 times 10 to the fourth centimeter cubed. So now I have the mass that I want in my correct units, and I have the density that I want in the correct units. And so these are the two values that I'm going to place into my mass over volume. My mass is 5.59 times 10 to the fourth grams, and my volume is 5.72 times 10 to the fourth centimeter cubed. Now I just want to point out that 10 to the fourth and 10 to the fourth are the same values. So these actually are going to cancel out. And even if you don't cancel these out, your calculator will give you the right answer. And my calculator gives me a very long number, a repeating value actually. And so I look back to my sig figs. Each value has 3 sig figs. This is my last allowable digit. I look to the right, that's less than 5, so 0.977 grams per centimeter cubed is the final answer. So this person should float on water, since water has a density of 1 gram per centimeter cubed.